Alright, this is going to be some basics on covalent bonding. First off, let's just talk about the difference between covalent and ionic. The difference between covalent and ionic can be summarized by differences in electronegativity. Electronegativity, of course, is the pull an atom has for electrons and other atoms. So covalent bonds have a low difference in electronegativity. You could summarize this by thinking about it this way. It's mostly nonmetals bonding together that form covalent bonds. If you draw a really cheap periodic table here, you have the zigzag line, which is your division between the metals and, of course, the nonmetals. If it's nonmetal plus nonmetal, it's probably covalent. If it's metal plus nonmetal, you're going to end up having a huge difference in electronegativity, and it's going to be ionic. So ionic bonds, of course, have great differences in electronegativity. Now, there are examples of covalent bonds that do have differences in electronegativity. An example would be, say, a carbon-oxygen bond. Oxygen is more electronegative than carbon. So the two electrons being shared between these two are mostly going to reside closer to the oxygen than they are the carbon. So what we do is we have a symbol to represent the partial charge that's formed. It's called sigma. It's a symbol that looks like that. And because the electrons are being drawn away from the carbon and towards the oxygen, carbon forms a partial positive charge. And you end up with a dipole pointing towards the more electronegative atom. And that's what polarity really is. Now what we're going to do is we're going to do a basic example of bonding with Lewis dots. I'm going to use phosphorus trifluoride as my example. Lewis dots work really well for showing structures with covalent molecules. Phosphorus has 5 valence electrons. Let me draw the 5 valence electrons around phosphorus. And then fluorine, each of these fluorines, of course, has 7 valence electrons. So I'm going to draw one there. Now that I know the dot representation, I'm going to draw 2 others really quickly. So each of these have an unpaired valence electron represented by the Lewis dot on the top. Alright, so the center atom for any molecule that you ever make is going to have the lowest electronegativity and also typically the most unpaired valence electrons. So each of these are going to be paired up by the fluorines, and what you're going to end up is with a Lewis dot structure looking like this, with phosphorus with its unbonded pair, and then you have the fluorines surrounding phosphorus. Now, if in your head you were like, wait a second, those were unpaired valence electrons, and what you did is you showed this is on top, and now that unpaired valence electron looks like it's being shared with the phosphorus down below, it's okay to imagine that fluorine with its unpaired valence electron at the bottom. Remember, these symbols just help us reason out how these molecules form and what their structures look like. So what you end up with are 3 bonding pairs and 1 unbonding pair where there's no bond being formed, but this pair is by itself. What we typically like to do is we like to draw lines to represent the bonding electrons in a Lewis dot structure. But we leave all the non-bonding pairs drawn out. Now that's the basic of how to draw a Lewis dot structure. Don't forget that the more electronegative atoms are typically going to be on the outside. The least electronegative atom is going to be the central atom, and that central atom typically is going to have the most unpaired valence electrons as well.